We are continuing now to move to different questions on this NECTA exams, NECTA questions on this part of logarithms. We have this kind of question, NECTA of 2007, question number 5. So without using table, evaluate now the logarithms of 2 log 5 plus 4 log 2, then minus 1/3, and then log of 64. So it is very simple. This kind of question now you can solve in this way. You have this kind of question, 2 log 5 plus 4 log 2 minus 1/3, then log of 40. 64. So when you find the number which is already here found before the logarithms are already foreign, this was the 2 that before the logarithm, but also here you have 4. Just move this to this side, turn back to this side. Just turn back these numbers to this side. Then it will be logarithm of 5, then exponent to this one, plus logarithm of 2, then exponent to this 4 after, turn back. But also logarithm minus logarithm of 64, then based in this one, exponent 1/3. So it will be in this way. Find the solution, the value of, after turning back at this number, then it will be logarithm of 5 squared is equal to 5 times 5. It means is equal to 25 plus this 2 exponent 4, the value of 2 exponent 4, it means it's 2 times 2 times 2 times 2 is equal to 16, minus this logarithm of this one. The value of this one is equal to putting the number, even if it was a1/7, equal to putting this number in side form, then this 7 here down at the denominator, you put it here. So taking this 64 now, 64, then 1/3 equal to, taking this 64 into the side form, that is this 3, put it here. Then you find this cube root of this 64. Yes. So now this is logarithm of 25 plus logarithm of 16, then minus this logarithm of cube root of this 64. Find on this cube root of 64 using the prime factorization. Just for 2, you get this one. 32 by 2 you get this 16, by 2 you get 8, by 2 you get 4, by 2 you get 2, then by 2 you get what? 1. So because it is cube root, just take these 3 numbers, 1, 2, 3, put and correct 1. 1, 2, 3, put and correct 1. So you have only 1, 2, 1. So this 2 times 2 you get 4. So it means that the value of this cube root is equal to 4. It means 4 times 4 times 4 equal to what? To 64. So you just continue with your scenario. This logarithm of 25 plus logarithm of 16 minus logarithm of 4 you get in this way. Just look now on the other laws of logarithm. You have plus and you have minus. So this minus in logarithm is so powerful compared to this plus. You just start with this. The same base, 10, 10, but you have the number 16 and 4. Because they share the common base, you just put here 10 at the base of 10, then 16 over or divided by 4, you get what? 4. So you still having this logarithm of base 10, then 25 plus logarithm of 10, then the logarithm of 4 base 10 that you have got there. So you have remained on this positive. Having the same base, use the product law. So product law, just they share this, the logarithm of the same base 10, then this, because you have this plus, just multiply 25 times 4, you get what? In this way, you will get 100. So the logarithm will be logarithm of 100, then base 10. Find the relationship between this number and this one by prime factorization. Use the number, the base that you have here with this one. Put here outside this base, put here outside, and this number just put here inside. Then you find by prime factorization, you find that this 100 is equal to 10 squared. Then you write now your equation, this one, equal to logarithm of 10. Then here, inside this there is 10, which is square. So it is 10 square. So having three numbers now here is applied on the exponent law that when you have three numbers, 1, 2, 3, 1 will fall down. That's why these two now fall down. So in this way, you have two logarithms of 10. So having the logarithm also 10, then base 10 equal to 1. Even if you find maybe logarithm of 3, base 3, then 3. This is equal to 1. Even logarithm of 5, this is equal to what? To 1. So here now, logarithm of 10 is equal to 1. So 2 times 1, you get 2. So the value of all this now is equal to 2. So it is easy. But also now let us shift to this kind of question. It's very simple. It's very simple. Let's see. So it is NECTA Form 2 2012. NECTA Form 2 2012. The question says, states that given a solution, this is solution, it is NECTA 2012. Then question number, it is question number 19. Just to find the value of, you have logarithm of x, base x, then 1 of 8 equal to negative 3 over 4. So this one is very simple, very simple. When you find the logarithms in one side and the other question, the other side, there is no logarithms, it is very simple. You just change this logarithm into exponential form. So the number or the base that found here, you just shift in this side in this way. Then the logarithm here, it will cancel out, it remain with 1 of 8 equal to x. So when you move this number into exponential form, you just start on the ways on the knowledge of this exponential form, how it operates. So x, when it moves in this side, you get it will be x, then exponent negative 3 or what? Over 4. Then you find the value of x here now, because the logarithm is already cancelled here. So in order to get the value of x, you just put in this way, 1 is equal to x negative 3 over 4. So here now, just multiply by 4. And multiply by 4, then multiply by what? Just, yes, in this way. So you get 1 over 8 exponent 4 equal to x. Then in this one will cancel out. It will be x negative what? Negative 3. So here, I just find the value of x. So 1 over 8, then exponent 4. It means 8 times 8 times 8 times 8. 8 times 8 is equal to 64. So 64 then times 64, you get a certain number. You just consider now here to 1 over 8, then 4 equal to 1 over x. Then what? 3. X over 3. It will be, in this way. So writing the number, the exponent or the negative exponent. For example, maybe you have this 1 over a. So writing this equal to writing a negative 1. So 1 over z equal to writing z negative 1. So what about this one? So 1 over 2 square equal to writing 2 negative in this way exponent. So how about this one? X now negative 3 equal to 1 over x then 3. Or 1 over x then exponent what? Exponent 3. The same. This one and this one are the same. So just now continue here to find the value of x. So you will do this. just put the cube root both sides, cube root both sides, then this one and this one will cancel, but the cube root here, 3, then here cube root 3, it will cancel this one and this one. So you get 1 over x equal to 1 over 8, then 3, I mean 4, then cube root of what? Of 3. So it is very simple. So you get now the 1 over x equal to this one, 1 over 3 to 1 over 8, then exponent 4, but also times 1 over 3. This one, the cube root, the way you can operate this cube root into this one, into fraction, it will be 1 over x equal to 1 over 8, then you have 2 exponents, you can multiply each as you get 4 times, it will be 4 over what? Over 3. So it will be 1 over x equal to, here you will get the answer to be in this way, 1 over 8, then 4 over what? Over 3. But also it was just to find the value of x. You just operate on it, is you have been looking on this side, you just 1 over 3, then 1 over x equal to 1 over 8, then here it will be this one. When you look on the cube root of this one, it is 1 over 2. So you get 1 over 2, but having this what? 4 here again, you have remained with 4. But 1 over 3, I mean the number which is exponent of 1 over 3, you find it is what? The cube root of that. So the cube root of 1 over 8, it is 1 over 2. But you still having this one 4. That's why it is 1 over 2, then 4. So 1 over x, and then it will be 1 over 2 times 1 over 2 up to this exponent, you find it will be 16. Then you multiply, because you get x equal to 16. So the value of x in this scenario now, it will be 1, it will be 16. So it is very simple. Just the matter of basic mathematics, just apply in order to get the value of x here. Thank you for listening.